There have always been two things which I wanted to share with students regarding eigenvalues and eigenvectors. First thing is, when a matrix of this type is being given to you, how do you find its eigenvalues? If that's the question, then in the exam, usually we go in a rush to finish the question paper, answer the question paper on time, and we forget to notice that this is a triangular matrix. Triangular matrix. Okay, once you know that's a triangular matrix, I'm obvious about it eigenvalues. What that is in the from the properties of eigenvalues, we usually learn properties of eigenvalues. Soon after discussing how to find eigenvalues and eigenvectors, I'll be studying about the properties or theorems on eigenvalues and eigenvectors, in which there's a property called for a triangular matrix, the diagonal elements are its eigenvalues. Okay. So, this is clearly an UTM, the upper triangular matrix. Okay. Upper triangular matrix. Okay. So, what would be its diagonal elements? 1, 2, and minus 2. Hence, lambda 1 is 1, lambda 2 is 2, and lambda 3 is minus 2. Now, students will ask me, ma'am, if this is a 10 mark question or if it's a 5 mark question, instead of going with how do we usually find eigenvalues is, I consider the characteristic equation that A minus lambda I is equal to 0. This is my characteristic equation. Okay. I start with this equation and hence go finding out the eigenvalues. Then usually students ask me, ma'am, if we write like this, do we get full marks or do we tend to lose marks in the exam? No. What I will say here is, before writing that the eigenvalues lambda 1, lambda 2 and lambda 3, you will make a statement saying clearly that the given matrix is a triangular matrix. The given matrix is a triangular matrix is the statement that you will make, and hence its diagonal elements are its eigenvalues is what you will write, and then directly write the three eigenvalues or list the three eigenvalues 1, 2 and minus 2. Okay, there's no problem if you write like this. If you write directly like this, you will not lose any marks. Otherwise, you can just write the characteristic equation for the matrix and say the same statement again. This statement you will bring here. Okay, you will write here and then directly write the eigenvalues for which you don't lose marks, guys. Apart from this, there's one more thing which I wanted to share. I'm sure some of you are aware of the shortcut to find eigenvalues and eigenvectors, but then still there are many people who are struggling with the direct procedure where it involves too complex calculations and then simplifications, because of which I thought I will make a video on finding eigenvalues, which is the shortcut. Now, this is a 3 by 3 matrix. I am being given a 3 by 3 matrix for which I am asked to find out the eigenvalues. How do I do it? When it is a 3 by 3 matrix, then obviously my characteristic polynomial, of course, I will write characteristic equation is that A minus lambda is equal to 0. I will start with this. And then if you want, you can just insert your lambda. Determinant is a number. So I will enclose determinant in lines, guys, and not in square braces, right? So I will write minus 2 minus lambda, 2 minus 3, 2, 1 minus lambda, minus 6, minus 1, minus 2, and 0 minus lambda is equal to 0. How you have got it if you ask me? Just see here. My A is 2, 2 minus 3. Okay. 2, 1 minus 6, minus 1, minus 2, 0 is my A. Right? This is my matrix A. Minus. What is lambda I? I know. A 3 by 3 identity matrix would be 1, 0, 0, 0, 1, 0 and 0, 0, 1. If I multiply I with lambda, I'll be getting lambda 0, 0, 0 lambda 0, 0, 0 lambda. You can clearly observe that other than the diagonal elements, rest all elements are 0 in the second matrix. So once I subtract first matrix, second matrix from the first, I'll be getting the resultant to be something like this. Okay. Because of which the change will be only in the diagonal elements. You write this equation. Characteristic equation is det A minus lambda is equal to 0. Then you write clearly what would be, how does det A minus lambda look like in matrix format. Then you start your shortcut for which you won't be losing marks. Since it's a 3 by 3 matrix, I'll be getting a polynomial of degree 3 in lambda. So lambda cube plus lambda square lambda and a constant term will be there is equal to 0. This is my equation because on the right hand side I have 0. Yeah, coming to the shortcut. Lambda cube coefficient is always 1, guys. And before writing lambda cube coefficient, I should make a mention of the sign as well. That is, when I am finding determinant, first element sign would be plus, the next element sign would be minus, the next element sign would be plus, and the next element sign would be minus. Or in other words, alternatively, plus minus signs will come. Now coming to the coefficient of lambda cube. Lambda cube coefficient is always 1, guys. Because it's shortcut, no reasons for it. You just have to remember. Now coming to lambda square coefficient, it would be trace of A. Trace. Trace is nothing but sum of diagonal elements. Sum of diagonal elements. Okay? Right. Trace is nothing but sum of diagonal elements. Now what happens to this lambda coefficient if you ask me? It would include all minors involving diagonal elements, minors involving diagonal elements, and this would be nothing but det A. You can say, ma'am, this procedure is not shortcut, it is very long, you might say, but then guys, regarding the sign I'll be sure of, and then det A would be a bit difficult, but otherwise remaining things are very trivial. So I always suggest you to go with the shortcut. Once I get the equation, do remember to carry your calculator. Make use of the calculator and finish off finding the values for lambda. Okay. Trace of A. Coming to trace of A. What is trace? Trace is nothing but sum of diagonal elements. What are the diagonal elements for the given matrix? There's a minus 2, a 1 and 0. So minus 2 plus 1 would be minus 1 and 0. Okay. So minus 2 plus 1 would be minus 1. So trace of A value would be what? Minus 1. Already there is a minus. So this minus and this minus goes to plus. Okay. Yes. Now coming to the minus involving diagonal elements, just see here. I will write them clearly. Observe. Minus 2, 2, 2, 1 plus 1 minus 6 minus 2, 0 is the another minor. It has, just observe, 1, 0 are the diagonal elements, minus 2, 1 are the diagonal elements. Now, one more minor I'll be getting with the diagonal elements, minus 2, minus 3, minus 1 and 0. Or, in other words, all the minors involving the diagonal elements as the diagonal elements for the minors as well. What is a minor? Minor is nothing but the determinant of a submatrix, guys. Determinant of submatrix. Now, when is a determinant possible? Only if rows and columns are same. So, if I have to delete a row from a square matrix, then I also have to delete a column to make it again a square matrix. Or in other words, it's nothing but the determinant of the submatrix. Determinants are possible only for square matrices. Now, let's add the minors, guys. What would be the value of the first minor? Minus 2 plus 4 plus 1 into 0, minus into minus is plus, but then AD minus BC, so there is another minus here. Of course, this is 0 minus 6 2 is 12, right? Again, this is 0, minus 2 into 0 is 0, minus 1 into minus 3 is 3, minus 3. So add all the elements, minus 2 plus 4 is 2, 2 minus 12 is minus 10, minus 10 minus 3 is minus 30. Okay, minus 10 minus 3 is 30, minus 30. Now, this has a plus sign here and then I've got a minus 13 here, right? So, accordingly, I will insert. Let me finish off the procedure, then show you what the equation turns out to be like. Now, coming to det A. Det A, use any row, any column, find accordingly. Here, since I have one element in the last row to be 0, I will go with finding out determinant with the last row, guys. Because I don't need to find one minor. because 0 into anything would be 0, right? So I will start with minus 1, the first element in the last row, minus 1. Okay, how do I find the determinant? 2, 6 minus 12 plus 3. Okay, and then the next element would have a minus. Minus is there and minus 2 is also there. So plus 2 it would be. And then coming to the determinant, minus 2 into minus 6 is 12. 2 threes are 6. There's a minus sign and then it's a plus. And then the third one would be 0, guys. Whether it's a plus sign or a minus sign, it's a 0. Minus 12 plus 3 is minus 9. Minus 9 into minus 1 is 9 plus 12 plus 6. 12 plus 6 would be 18. 18 into 2 would be 36. Okay, 36 plus 9 would be 45, right? Now let me write finally the equation, lambda cube. I've got a minus 1. Actually, there was a minus, so it would be plus lambda square. Okay, but then I have got the sum of the minors to be minus 13. There was a plus, but then lambda will be having a negative sign. Minus 13 lambda plus 45 is equal to 0. Okay, yeah. So if you find the roots using a calculator, what you will do is you will go to equation and then give the values of A. A would be 1, B would be 1, C would be minus 30, D would be 45. You will be supplying these values and press equal to and you will get the values. Now I have the values for it. Lambda turns out to be minus 3 and 5. I think I am clear, right? I am clear with the shortcut. Lambda cube quotient is always 1. Alternatively, plus and minus signs will go because I am finding the determinant. Characteristic equation is nothing but the determinant, right? Now, lambda square quotient would be trace of A. Lambda quotient would be the sum of all the minors involving the diagonal elements as the diagonal elements of the minors. I think I'm clear, right? And then the constant term would be nothing but det. Okay, I will find insert and make my job easy. Do follow the shortcut and not the whole procedure to find. I've seen many students struggling doing the procedure. I hope this should be helpful to all of you. Thank you.